Okay, welcome back. We're going to do part 2 now for section 4.3. So this part is on compositions. All right, so at the bottom of the page we just ended on, we're going to talk about the notation for composition. And basically remember that a composition means you're putting one function, the answer of one function inside another function. So it's not multiplying, it's not dividing, it's a new kind of operation. And you denote functions by either, or compositions, by either putting that little open circle between it. Some of you guys read that as fog, but you read that f of g of x. That's how you read that. Or you can put your answer or the problem this way, f of g of x, with the parentheses between f and g. Okay? So I want to make clear that you understand that this is a composition, okay? This is different than if you see this. A lot of you make this mistake. This is a multiplication problem, okay? Notice there's nothing between f and g, okay? That says f times g of x. This has a parentheses between it, so that's a composition. Now, this also means composition, right? That's the composition. If you see this, remember that that's multiplication. A dot means multiplying. The open circle, that's your composition notation. So it's very easy to get these four confused. So these are your compositions, okay? These are multiplication. So be careful with that when you're doing your homework, because if you do the wrong thing, you'll get the wrong answer. All right, so the other thing before I flip over is now we're going to do domain, and this time it's a little different, so be careful with this. The domain for any composition is the domain, you have to look at the domain of the inside function, so that's the function closest to x, might not be g, depends on the letters, but the function inside, and then the domain of the result. So remember on the other ones we had to do both functions. Well, now we just need the inside function and the result. Okay, so a little bit different when you're finding the domain. All right, so let's look at these two functions, f and g. We're going to compose them, and then we're going to find the domain. All right, so remember this is f of g of x. That's what it looks like. All right, so when you do this, let's remember whatever is the function closest to x, which is this one, you're going to put this function in this function. So right here, you're going to replace this x with this function. Okay, so that would look like 4 over 2 over x plus 5. Okay, that's what that would look like. All right, so we're going to simplify the denominator. We got to add, we got to have like denominators. So leave the 4 up there. So all I have to do is multiply the top and bottom of this by 5. Remember it's over, I'm sorry, by x. This is over 1. So our common denominator is going to be x down here. So we're going to multiply this and this by x. So we're going to have 2 over x plus 5x over x. All right. Okay, so that's going to end up giving you 4 over, and then you can now add your numerators together. 2 plus 5x over x. Okay. Now we can flip it and multiply. Remember, we're dividing fractions. So we're going to do 4 times, and now we can flip this. X over 2 plus 5x. And then we just multiply the top. So that's 4x over 2 plus 5x. All right, so there's our answer. All right, so now we need the domain of the inside function, which is, in this case, g of x. Okay, so what is the domain of just this? Well, that would just be x can't be 0. Now we're going to do the domain of the result. And that's all we need to worry about. So the domain of the result is this can't equal 0. So you need to work that out. X plus 5x can't equal 0. Subtract 2. Divide by 5. We get negative 2/5. So there's our domain. X can't be 0 and x cannot be negative 2/5. The top is fine here. It can be whatever it wants to be. All right, so we're going to go from negative infinity to the smaller number, negative 2/5. Then negative 2/5 to 0. And then 0 to infinity. Okay? All right. Let's do another one of these. So now we have a radical and we have a rational function, and notice f is the one closer to x. So I'm going to rewrite it this way just to practice. All right, so we're going to take this function, the function closest to x, and put it inside here. So where that x is, that's going to be square root of 6 minus x. All right, so we're going to do 3 over square root of 6 minus x squared minus 5. So we put function f inside function g. Always the one in the middle, closest to x. All right, this is nice because when you square a radical, it undoes itself. So that just gives you 6 minus x, and then you have the minus 5. So we're done. 6 minus 5 is 1 minus x. So there's your answer. Okay. So now we need the domain of the inside. Inside this time is f of x. Okay, so what's the domain of this? Remember, you have to set that greater than or equal to 0. I'll do that with you. Set what's under the radical greater than or equal to 0. Solve that. So I'm just going to move the x over. Make it positive. So remember, you're reading this backwards. X is less than or equal to 6, right? The greater than sign is pointing towards the 6. If I write it the other way, that's really what I have. So this is just all numbers less than or equal to 6. Okay, be careful with that. For the result, our domain of the result, let's see what we got. 1 minus x cannot equal 0, right? So again, move the x over, make it positive, so x cannot be 1. All right, well, think about that. We have to have numbers less than or equal to 6, and x cannot be 1. Well, numbers less than or equal to 6 are all the numbers from negative infinity to 6, and then we're going to have to take out 1, right? So that would go from negative infinity to 1, and then 1 to 6, and it can be equal to 6, so we're going to use a bracket. Haven't had many brackets yet, so there's the first one where we have it. So pay attention to your symbols. Okay? All right, let's try a couple more. All right, so 2 more functions. This time we're going to find f of f and then g of g, and that can happen. So that just means we're going to put the same function inside the other function. So this looks like f of x, if you're writing it that way. So we're going to take this function and put it in this function. So that's kind of weird, but 2 over 7, and then in place of x, we're going to put 2 over 7x. That's what that would look like. All right, we're going to multiply the bottom, leave the 2 in the top. So this is in the numerator. So, well, actually, we can cancel these 7s out. So these will cancel out. So we're just left with 2 over x. Then we are going to flip this and multiply. So that's 2 times x over 2. Now the 2's cancel, so we're just left with x. Okay? All right, so domain of the inside function, just be x can't be 0, right? You set that not equal to 0, so the only thing you can't use is 0. And then the result, that's all real numbers. So my domain is all real numbers except for 0. Okay? All right, now we're going to do the same thing with g of g. So g of x. So we're going to take this and put it in here. So that would be x squared minus 6 squared minus 6. Okay, so this we're going to have to FOIL out. So we got to do a little bit of work. So x squared minus 6 squared means this, right? So we're going to FOIL that, and then we'll do the minus 6 at the end. All right, so first outer, inner, last. So first x squared times x squared is x to the 4th. Outer would be negative 6x squared, and inner is also negative 6x squared. So that will give you negative 12x squared. And then negative 6 times negative 6 for last is a positive 36 minus 6. So now we're at x to the 4th minus 12x squared 36 minus 6 is 30. Okay? All right. So I'm just looking at factors of 30 that add up to give me 12 if I could factor this. So that would be 1 times 30, which doesn't add up to 12. 2 times 15 does not add up to 12. 5 times 6 does not add up. 3 times 10, so there's nothing that adds up to 12. So thank goodness we don't have to factor that, but we did need to check. So there's our answer. The domain of this would be all real numbers. That's just a polynomial. The domain of the inside function is also all real numbers, another polynomial. So the domain of both inside and the result are both all real numbers, right? So that's your answer. That's just a polynomial, so no problems with that one. All right, last one. Now we're not doing the domain anymore because you'll notice now instead of x in here we have numbers. So anytime you have a number in there, you're going to get a number answer. So there's no domain to worry about. All right, so remember h of g of negative 2/3. So these you work a little bit different. You're going to start with what's closest to the number. So you're just going to find g of negative 2/3. So we're going to find g of negative 2/3 first. Okay, that's what you do first. So we're going to put negative 2/3 in here. Okay, so let's do that. G of negative 2/3 equals, work this one out with you. So work that out. So negative 2/3 times 9 is negative 18/3, which is negative 6 minus 4, which gives us absolute value of negative 10, which is 10. All right, now that's not our answer. This is a two-step process. So the first thing you do is find g of negative 2/3. Well, you just found it to be 10. So now you're going to replace 10 with g of negative 2/3. So that leaves you h of 10 now. Okay, so we substituted in the value of g of negative 2/3, which we got to be 10. Now we got to do it again, and we're going to find h of 10. So now we're going to put 10 right here. So square root of 35 minus 10 is the square root of 25, which is 5. That's your answer. You only get one answer, okay? But these are two steps to get to your final answer. All right, so let's try that again. H of, oh, I almost did that. Gave you this and I even mixed it, and I did this on purpose. All right, look at part B. That is not a composition, that is multiplication. So see, I almost made that mistake. So you got to be real careful when you look at the problems, okay? So this is multiplying. So that's what we did in part 1. So multiplying means just take h of negative 1 times f of negative 1, right? That's what we did earlier. So be careful with that. Again, I just about did it as well. So it's an easy mistake to make. So pay attention to the notation. All right, so all we have to do here is put in negative 1 to h. So 36 minus negative 1. 35 minus negative 1 is 36. Square root of 36 is 6. And then f of negative 1. So put negative 1 in here, square it first. So that would make it positive 1 times 3 is 3. So 1 minus 3 is negative 2. Multiply that together. So there's your answer. Okay, so these look very similar, but keep in mind they are not. So watch your notation. All right. Last page is a little bit more with evaluating these compositions, and then we're going to look at the graphs. Okay. All right, so notice my problems here. These are all compositions. Okay? So I don't have any tricks on this one for you to do. All right, so we're going to evaluate f of g of 4 or state if it's undefined. Sometimes if you get 0 in the bottom, you can't do it. Okay? So remember, we're going to find g of 4 first, and then we're going to put that answer in place of g of 4. Okay, so remember, f of g of 4. That's what we're looking for. So we first got to find g of 4. So we're going to put 4 in here. So it's 4 over 4 minus 2. So that's 4 over 2, which is 2. All right, so now you found what g of 4 is, so you're going to replace that with 2. All right, so now we're going to go to function f and put 2 in here. So 4 times 2 plus 1. So that's 8 plus 1. So there's your final answer. All right. B we're going to do backwards. We're going to do g of f of 4. All right, so we're going to start by finding the inside number, f of 4. Okay, so we're going to put 4 in here. So 4 times 4 plus 1. 16 plus 1 is 17. So f of 4 is 17. So now we're going to replace that with 17. And now we're going to plug 17 into function g. 17 over 17 minus 2. So that's 17 over 15. Okay. All right, g of h of 1. G of h of 1. So we're going to start by finding the inside h of 1. All right, I'm not going to write that one out. We can do that in our head. 1 plus 3 is 4. Square root of 4 is 2. So we're going to plug 2 in for h of 1. And now we're going to go to function g and plug 2 in here. So that's 2 over 2 minus 2. So we end up with 2 over 0. So that is undefined. No answer for that one. That happens. Can't divide by 0. All right, and the last one, h of g of 1. Start with the inside, g of 1. Plug 1 in here. 1 over 1 minus 2. That gives me 1 over negative 1, so that's negative 1. So we're going to replace g of 1 with negative 1. And now we're going to put negative 1 in here. Negative 1 plus 3 is 2. So we end up with the square root of 2. Okay? All right, so just be careful with compositions versus multiplying. Okay? All right, now, the graphs at the bottom, typically, sometimes you guys have a little bit of trouble with the compositions. So let's pay attention to the notation and what we're doing. All right, so we're going to use the graph. Function f is kind of the thinner line, the check mark, and then the bolder curve is g. So pay attention to that. Remember, you're doing, this is a composition. There's a parentheses there. This is a composition. This is a composition. Okay, so make sure you're paying attention to that. So remember what we're going to do first. Find the inside value. So we're going to go to function g, go to negative 3, and find the y value. Also, be careful on here. Here's your origin. This is 0, 0 right here. Okay, it's not in the middle. So you see the arrows going this way. So that's your 0, 0 point. So just be careful. So we're going to go to negative 3, 1, 2, 3. Find that point on function g. So the y value of that is 1, 2, 3, right? So that's the ordered pair, negative 3, 3. All right, so g of negative 3 means find the y value, 3. So we're going to replace 3 with that. So now we're going to go and look for f of 3. Okay? Well, f of 3 is over here. Count 3 from the origin. 1, 2, 3. There's your point on function f. That's the point 3, 0. So f of 3 is the y value here, so 0. All right, so we're going to do the same thing 2 more times, and then we're going to do the same thing on another graph just to practice, okay? All right, f of 5. So go to 5, 1, 2, 3, 4, 5. Find it on function f, 1, 2, 3, 4. So that's the point 5, 4. So f of 5 is 4, so substitute that in there. And now we're going to go to function g at 4. So 1, 2, 3, 4, go up to g, right there. That's the point 4, 3, right? 1, 2, 3, yep. So g of 4 would be 3, the y value. All right, part C, remember that's the same thing as this. I like doing it this way because you can kind of see what you're doing first and what you're replacing. So we're going to go to g of 0. So here's 0. G of 0 is right here. That's the ordered pair 0, 1. So g of 0 is 1. So now we're going to find f of 1. So we're going to going to go to function f at 1. So here's 1. Here's function f. That's the point 1, negative 1. So f of 1 would be negative 1. Okay. So these 2's kind of get in the way here, but again, that's 1, 2. So I don't know why they only put 2's there. That's what they did. So just count your blocks. That's a little bit easier. All right, so we're going to do the same thing with this graph. So f is the red graph, and g is the blue one. So let's do the same thing. So again, if it's easier, like it is for me, to do it this way, I like that notation better. So first I'm going to go to function g at 4. So go over to 4, 1, 2, 3, 4. Function g is right there. That's the ordered pair 4, negative 2. So g of 4 is negative 2. And now we're going to find f of negative 2. So f is the red graph. So right here, negative 2. The answer would be 2, right? Negative 2, 2. So that's that y value. Okay, g of f of negative 3. And you can try these and pause the video and see if you're getting these right before I do it. That would be good before you try your own. Try these last 2 on your own. Okay. All right. So we're going to find f of negative 3 first. So we're going to go to negative 3, go up to f. So that is the point negative 3, 5. So f of negative 3 is 5. So now we're finding g of 5. So we're going to come way over here to 5, find it on g, which is 5, negative 3. So negative 3 will be our answer. All right, lastly, f of negative 1. Yes, you can do that. f of negative 1. So we're going to find f of negative 1 first. So we're going to go to negative 1, go up to f. That's the point negative 1, 1. Right? Negative 1, 1. So that is 1. So now we got to find f of 1, which is over here. Go up to function f. That's the point 1, 5. So 5 would be our final answer. Okay? All right. So these are a little confusing for some of you, so practice on those. We've got all the work now for compositions and for the operations for this section. So you got plenty to work on with your homework. Again, we're nearing your first test, so make sure you're going back and studying, and email me if you have any questions on any of the topics, okay? All right, have a good rest of the day.